In this video, we're going to be talking about linear functions. Linear functions are functions that, when we graph them, create a straight line. What we're going to do now that's a little different is really focus on describing the input and the output values, with the input values being x and the output values being y, or later we'll learn f of x, and then we're also going to learn some new notation. The function y equals x minus 1 takes the input value and plugs it in for x in the equation to give the output value. So take a second and think about what each of these functions are doing with the input value. In this example, we're taking the input value and subtracting 1 to get our output value. So what are we doing for each of these? We're going to pause the video for a moment, and then when you're ready, click continue. So here's what each of these functions are doing. When we have the questions in this column here where it says when x equals 9, what is y, we're now going to do whatever our rule is or whatever our function is. If x equals 9 and our function is y equals 4x, then we need to multiply our input 9 by 4 to get what y should be. So when x is 9, y is 36. So in this next problem, we're going to take our input and add 3. When x is 9, y is 12. For this last function, we have to multiply our input by 2/3 and then subtract 5. When we multiply a fraction and an integer, we can just put the integer over 1. So I can multiply 2 times 9, which is 18, over 3 times 1, which is 3. 18 divided by 3 simplifies to 6. Therefore, y equals 1. So when x is 9, y is 1. This next section is new. We're talking about function notation. So the most popular letter used to name a function is the letter f. But almost any letter can be used. Just like how when we're talking about variables, the most common variable we use is x, but you could use any variable. This part we say f of x, or the function of x, equals 2x, then f is the name of the function, and x is the input, and the 2x tells you to multiply the input by 2 to get the output. So really, even though this is new function notation, f of x equals 2x is just the same as y equals 2x. This is the exact same line. They contain the exact same points, or in this case, if we're talking about a function, we might say the exact same set of input and output values. It's just a new way of thinking about what we've already learned. So what we're going to do now is, using this function notation, we're going to do just as we had done before, where we figure out what the corresponding output value has to be when given an input value. In this case, our input value is 4, right? We picked a number here that we're plugging in for x. In the original function, we have just x written here as our variable. Since we're setting it equal to 4, we're saying when x is 4, what is our output variable? What is f of 4? That's how we describe this. Anytime we have something like this in parentheses, we can say f of whatever is inside the parentheses. So if it's like this, where it's f of x, we would say f of x, or the function of x. That is written like that. If we have something like this, where the number inside the parentheses is 4, we would describe this as saying f of 4. So f of 4 for this first function means we're going to multiply our input value by 5. That's going to be 5 times 4. So f of 4 is equal to 20. Now in this next example, we have f of t instead of f of x, but it's the same thing. We're still plugging in 4 as our input to see what our output value is. So f of 4 is equal to 4 plus 10. Therefore, f of 4 for this function is equal to 14. When our input value is 4, our output value is 14. Lastly, for f of a, this tells us that f of a is equal to 4a minus 7. So f of 4 would have to be equal to 4 times 4 minus 7. Therefore, in this last function, f of 4 is going to be equal to 4 times 4 is 16, minus 7 is going to be 9. So when our input value for this last function is 4, our output value is 9.